Hello students, welcome to the next slides. So far we have seen uh, several principles of object-oriented programming, and we have discussed in details four principles of object-oriented programming. So we also among them, inheritance is one of the principles that we have discussed. So here another applications of inheritance, the class object. uh, Object is a class that is a built-in class in Java library. So object class is supermost class in all class in Java library for all classes. So all other classes are subclasses of object class. So you can say that object is a supermost class, of all other class. So all classes inherit the methods defined in class object. So however, this method can be overridden in other classes, and you can also access this method in your own class. So there are several methods in object class. These are the some of them. These are some of them. So for example, method equals, which returns boolean, that takes object and compare with other object. Then hash code method that return integer hash code value for the object. So every object has some hash code value. So hash code to return the hash code value of any objects. You will see several times the toString method in different class. The string method basically return the representation of object, uh, and the get class method return a class that is identify the class of the objects. So these are some of the you know methods in class object. And what as I said, that the class object is the supermost class is an applications of inheritance principles of object-oriented programming. Typecasting is another concept how to convert one type of the informations to other type of informations. So so we in our compiler we have some automatic conversions systems. Say for example, if we want to deal with integer value with the double value, then integer value will be converted to double. If you want to deal with float with a double value, then float will be converted to double, and similar to integer will be converted to long. So these kind of things happen, basically uh, automatically. So this is called typecast, that casting from one type of information to other type of informations. So typecast can be implicit and explicit. So what is implicit and explicit, we will discuss about those things. And before that, we know that Java has 8 primitive numerical types. What are those? Double, float, long, integers, short, and byte. These are the 6, and we also have two more type, say for example chart type. So so here it's given some hierarchy of primitive numerical types. Double is has more precision than float, float has more precision than long, and long has more precision than int, and so on. So double is has more size than other, has more larger size than other type of informations, other type. So these are the hierarchy of primitive numerical data. So we said that implicit typecasting and explicit typecasting. What is implicit typecasting? That basically happen automatically. So higher types have more. We know that higher types has more precisions, and lower type are subtype of higher types. So So Java perform implicit, basically upcasting. Upcast, implicit upcast. That means if you deal with integer and float, we know that float has a larger size, so float has a higher precision than integers. So integer will be converted to float. That means upcast. That means lower type, lower size of information will be converted to higher type. So that's basically called upcast, and it happens automatically. You don't need to deal with, you don't need to perform write any code for doing any implicit conversions. So that calls upcast. So what about explicit typecasting in Java? In explicit typecasting is basically downcasting. So for example, if you want to convert float information into integers, that means you are doing downcasting. We know that float has higher size than the integers. So here you can see that we wrote some code int x assigned by in the parentheses integers than 3.7. We know that 3.7 is a float informations, and we are converting that float information into integers and then assigned to a integer variables. Since integer doesn't keep precision, so when we will convert to integers, that the precision of the float information will be removed. So the integers x will have 3 instead of having 3.6, 7 or 4. So that's called downcasting, and you have to do manually. That means you have to write some code to do some explicit typecastings. So this is another way to do some typecastings. So these are the mixed expressions. So here are float x assigned by 3 by 4. So that basically 3 and 4 are integers. So but after conversions, after after doing arithmetic, then it will assign to a float x. So x float variables. So it will be doing upcasting after doing operations. Then we do some upcasting uh, in an explicit way. We are converting integers, say 3 and 4, to float. That is upcasting. We know that float has higher precision than integer. Then after having the float information, then we do the arithmetic. Then we convert. Then we assign to the float x. Then finally we have 3 by 4, that is integers. Then we get some integer result, then we convert into a float informations. Then after getting the float information, we assign to a float variable x. So these are how to do some explicit conversions. So if we don't do explicit conversion, then if computer think that they need some conversions, then they do some implicit conversion if possible. So these are the things of typecastings. So in casting can be happen in the class also, class object also. For example, so we understand that object is the supermost class that has higher precisions, higher size, I mean superclass. So we can create an object, then we can have some we we can have some lower objects. Integer is a subclass of the object class. Then we can create some objects, and that object can be uh, uh, do some downcasting to keep in the integers. So this a thing is an object type, and this object type is converted to a integer type. Integer type is a subclass of object type. So that basically a downcasting, and we are doing in explicit way. Now we are going to cover another important topics is called exceptions. We basically need exceptions in our coding. Why we need exceptions in our coding, we'll talk about those things. So when Java program runs into an unexpected runtime error, the program terminates abnormally. What does it mean? So when you write a program, you probably have some errors. So our compiler basically detect those errors, then we fix those errors, and we have some programs so that can be run. But there are some situations where compiler cannot detect those mistakes, and those mistakes basically arise uh, when we run the programs. So our program can be terminated abnormally due to those reasons, and that's basically says that unexpected runtime errors, that the error which was not detected during compile time when compiler compile the programs, so that probably happened during runtime when we run the programs. So in these situations, in order to handle this situation, in order to avoid abnormal terminations of our programs, we need some exception handling mechanisms. That's why we should know how to write exception handling mechanism in our code. So if we have some unexpected errors during runtime, then our this exception handling mechanism can handle those situations. Let's start with an example. Say, for examples, in a scenario one, you have a three different codes. One code called knife code. So basically, a program's dividing by zero is an undefined operation. We know that any value that is divided by zero is basically giving some undefined operations. So if you do those arithmetic on terminal or in program, that basically give you errors. So if you write a program for doing those things, so and you have a knife code, you don't have any protections to handle the situations. So then if you run the programs, and if you have any situation when a value is trying to divide it by zero, then that time your program will be terminated abnormally. So you can fix this problem by if conditions, if statement conditions. Say for example, so you always check whether value is zero or not, which is used to divide other value. If it is zero, then maybe you can send some message to the user that no, you cannot send zero. And you can fix this situation using exception handler. So we'll see uh, uh, So we'll see those situations, all three situations in a code. Let's start with the first scenario that we don't have any protections. Say for example, so you can see that a user taking some input to variable input, okay, scanner using the scanner object. Then we assign that in first input to number one, and we assign that second input to number two. Then we do some arithmetic. Number one is divided by number two. So since we are taking some numbers from user, we don't have idea whether a user is giving zero for number two variables or not. So for example, so if you enter two integers, the first integer is 100 and second integer is 0, that means 100 is uh, dividing by 0. That basically giving some runtime error. Although you don't have any errors, so you run the program, but when you give 0 for the number two variables, then it's giving some runtime errors. So this is your program will be terminated, and this is a knife code. You don't have any protections, and this can make your program terminated. This is the second scenario. Say for example, we can fix this situation using if conditions, if else conditions. For example, we are taking input from users, and those input are keeping in number one and number two. Now we check that whether number two is not equal to zero, then we do arithmetic. If it is zero, then we can print divisor cannot be zero. Yeah, we can send a message to the user that you cannot provide zero. So that basically uh, uh, help to ignore terminations of your programs. And the number three, say the last scenario that we are trying to focus on this situation. That's how to use exception handling technique. So this is the mechanism. We can use exception handling mechanism to ignore this kind of terminations. For examples, in the we have the same code. We take some user input and we keep those input to two different variables. Now in the exception handling mechanism, we have two different blocks. One block is called try, another block is called catch. The try blocks basically keep eye on the given statement which are inside the try block. So the and try block always try to find out whether there is any problem or not. If they find any problem, they pass those informations to the catch section, and catch section handle the situations. For examples, we keep the all the sophisticated statement should be in the try sections. Then so try section keep an eye on the statement, and if it finds any mistakes, then it will pass the information to the catch section, and catch section handle the situations. So say for example, so we are trying to divide something, number one divided by number two, and we'll keep the results into the result variables, and then we print those informations, print some informations. So try block always keep on eye this arithmetic, because and this you know this statement also, printing statement also, if they find that number 2 is 0, then it will pass the information to the exception cast section, and then cast section will print the information in integer cannot be divided by 0. So this is kind of this is kind of an idea that the code that is more sophisticated, if you think that that code that code can arise some errors during runtime, then you should keep those statement in the try block. Then try block always keep eye on those error. If they find any mistakes, then they will pass those information to the catch section, and catch section will handle the situations. So for examples, if we try the two integer 100 and 0, then exceptions that basically printing the same things. An integer cannot be divided by 0, and then it will continue to asking user to give some different numbers. Okay, so these are the three different scenario of the same code. We can have knife code without protection. We can solve the situation using if else condition. We can solve using the situation. Yes, you can solve the situation using exception handling technique. So the advantage of exception handling is, mechanism is that it basically separates error handling code from normal programming tasks. Say a program has several codes, several methods, several statements. So the error handling code, the code that basically are sophisticated, you want to keep eye on those things. Those basically are separate from the normal code. Those are in the some blocks, try and catch. So that's why this is the good idea, basic good advantage of having exception handling mechanism in our code. So here you can see that there are two blocks, try and catch. Try blocks basically have all the business logic. So what need to be done? So the try block can can focus on those code. And if you have any trouble, that catch section basically deal with the troubles. If there are any issues. So there are several Java exceptions. Java has several built-in exceptions. In order to handle several situations, you can use these classes. Each of these are classes. These classes handles several different things. So far, we have seen that to handle, dividing by 0, we use some arithmetic. We can use some arithmetic exceptions class to handle those situations. If you want to handle if any class is not found, then we can use this exception class to handle the situations. Then there are several illegal access exceptions, IO exceptions, end of file exceptions, file not found exceptions, input mismatch exceptions. So these are all are bad situation when it can be happen during runtime, and these things can be handled by this class. We'll see one example. Say for example, this is example of input mismatch exceptions. So for examples, so a user taking some, yeah, a program taking some user input over here, then it keep those keep the user input to a variable number, and if it takes basically integers. So if a user give float variable or char informations, then it will you know handle the it will handle the situations. For examples, the a user is supposed to give integers for these number variables. Now if user try to give some float informations, and that is a violations of the program rules, and that should be handled by the try catch block. So try block will keep on try whether a user giving any different type of information or not. If any user give any different type of information, then it pass the message to the cache section, and then cache section handle the situation, ask user try again, incorrect input a integer is required. So you cannot give any other type of information other than integers. So you can see that this cache sections handles the input mismatch exceptions. So input cannot be mismatched with the rules. So these kind of situation can be handled by input mismatch class or objects. So this is one example of input mismatch exceptions. So far we have seen some examples of exceptions. Exceptions has some hierarchy. So we know that object is a supermodel class, and under that we have throwable class, and throwable class has two subclass, exceptions and error, and exceptions has several child class not found, IO exceptions, runtime exceptions, and runtime exception has more subclass, arithmetic exception, line pointer exception, index out of bound exception, illegal argument exceptions. So these are the exception hierarchy. So we'll basically in Java we'll basically handle these sort of exceptions handling techniques. In exception can be unchecked and checked. What is unchecked? So a system are thrown by JVM, a system error thrown by JVM. There is a little you can do beyond notifying the user and trying to terminate the program gracefully. So you cannot, control the situations. So basically, a unchecked exceptions, uh, you know, uh, a a system doesn't do check those error. However, a checked exceptions that basically a compiler force you to do something that you can check those errors before going to runtime. So those exceptions, those kind of exceptions, checked by compiler, and it will force you to write some protections before going to run. So we'll see those examples. Say for example, checked exceptions versus unchecked exception. Runtime exceptions, error, and their subclass are known as unchecked, because you can, and all other are checked exceptions. We have seen that this is runtime exceptions. So they basically happen. A compiler will not tell you that write some protections over there, these are unchecked. So if you do mistakes, then it will give some errors during runtime. But however, in some checked exceptions, say for examples, this IO exception is a checked exceptions. So if you write any code, if compiler think that it needs some uh, IO exceptions mechanisms, then it will force you to write some code to do some protections. And these are the check type exceptions. So these are the two different type exceptions, checked and unchecked exception. Checked exception basically, you know, compiler checked and ask you to write some protection, and unchecked exception compiler will not check those things, and it will not force you to write any protection, and this is your duty to write some protections to avoid some runtime errors. So these are some unchecked, exceptions, null pointer exceptions, index out of bound, you know, exceptions. These are the, some unchecked exceptions. So we have seen that try and catch block. A try can be followed by several catch block. So you can see that catch, this is one block, this is second block, and this is third block. And each catch block probably handles different type of exceptions. Probably these handles arithmetic exceptions, this handles null pointer exceptions, this handles input mismatched exceptions, and so on, so on. So a try can, handles different type, followed by several catch blocks. So a try block keep on try on keep eye on statement. If they find any mismatch, if they find any conflict, then it will pass the information to the appropriate catch block. When you write several catch block, you have to think about that what is the order should be for the multiple catch block. So you cannot write uh, super class before subclass. So if you write superclass before subclass, then uh, any exceptions will pass to the superclass. It will never reach to the subclass. So the right order is that you always should write subclass exceptions before superclass. We know that runtime exception is a subclass of exception class, so you should write runtime exceptions before superclass. And other thing is that we can have finally clause. Finally clause is some kind of default clause. If whether you run catch block or not, it always uh, run the finally block. So finally block is it some what are the statements you keep in the final block, it always should be run, whether it doesn't depend on the whether catch block run or not, whether try find any error or not, the final block always should be run. So these are the basic things of exceptions. You should read the textbook to find uh, all the exception related problems, and you have to do some assignment on exceptions handling mechanisms. These are last slides of this week, so you should read all the 4 slides and you should go for your assignments. I uploaded assignment, there is some due date, you should submit your assignment by due date. Thank you.